All right. It is 2 p.m. Eastern, so we will go ahead and get started. Here's the fun topics. My goal is to always get this topic done earlier than towards the end, and it just never happens because it's a lot. It's a lot of new stuff. So even folks that are somewhat familiar with the old 911 system, or legacy 911 system, as you know, as we've known for years and years and years, and the next generation stuff that's been coming, there's some terminology here. While folks may kind of have an understanding of how things behind the scenes go, it can be a little confusing. So while this is probably the most challenging section, I do have some cool things to help you remember some of the things that we're going to talk about. Some of the things that they have listed on the body of knowledge are not in the study manual, and I will be bringing that up to the folks at NINA. I have a working document right now with some things that I'd like to see changed in the study manual to make it a little bit easier and to include some of the terminology and things that are on the body of knowledge and are almost impossible to find. So I may have found the information for you. Some of it I don't fully understand myself, but I've at least found the definition for you so you can be pointed in the right direction, and I'll let you know which ones those are. But for the most part, we got lots of things to go over this week, and it took me a long time to figure out how to explain this stuff, but I actually enjoy it now because I have a better understanding of it, and I've been successful in helping explain it to others, and folks love my silly little picture drawings that I did to talk about how the next gen network goes and using the terms that we have here. So with that, let's get started. So as usual, welcome to the On Scene First NINA ENP study group. This is for the fall 2022 session. This is week 12. We have one more week left. Next week, I've pretty much covered all of the topics in the body of knowledge and the majority of the topics. Next week is probably just going to consist of some things that I may have missed, wrap up a few things, maybe review a couple of things, and go over a couple of very small topics that I didn't go over yet. And there may be one that you might be receiving via a video that I already have completed. It doesn't make sense for me to redo it if it's just a small section, and I can provide the video that I already have. So there's that. If you are finding this video before September 30th, 2022, just so you know, we are wrapping up this study session next Friday on September 30th. So I can't believe that it's already September 30th. But if for whatever reason in the next week you find this video and you want access to all of the materials for the fall 2022 study group, please register at the website that you see there, onscenefirst.com/training/study ENP. If you're finding this after September 30th, 2022, and you are planning on taking the exam in February of 2023 and want access to all of the recordings, all of the materials that I've provided, and all of the PDFs, then you need to email me and ask for that information, and I will add you to the Google group for this study session right now. I'm not doing another live session until January of 2023, and that is going to be for the spring of 2023. And just to be clear, if you haven't registered for your exam and you're going to, I highly recommend registering for each study group up until you take the exam. Because after each session, I have folks that reach back and share information with me on things that I should make sure that I go over if I haven't gone over something. So I want to say thank you to my premier study group sponsor. This study group takes a lot of time, and Rapid SOS has generously sponsored me to do the study group for you guys. It also allows for a few scholarships there. So make sure you shoot on over to their social media and websites and give a big thanks. And I want to say thank you to my podcast and media sponsor, NGA Next Generation Advanced. Their generous sponsorship of what I do allows me to provide free training and all kinds of cool things, and my podcast. So thank you so much to them as well. Make sure you pop over there and say thank you to them. So before we get started, I just want to review 3 terms. You know, one of the things that I know happened to me when I took the exam, and I wish I had spent some time just really understanding what the difference was between a policy, a proxy, and a protocol. Because in this section right here, we're going to talk about different policies. So we're going to talk about the policy routing function. We're going to talk about some proxies, and we're going to talk about some protocols. And I think if you just have a foundation of the policy, proxy, and protocol, when you look at what the element is in this particular section, you may be able to stop and say, okay, this is a protocol. So that means this is how it's done. This is a policy. This is why it's done. Or this is a proxy. This is being done on behalf of something else. So policy is a definite course or method of action selected from among alternatives. So a policy, if this, then that. So if there is a route that needs to be chosen as to where the 911 call is going to go, the policy routing function is going to be the policy, just like a policy in your 911 center. A policy says, if this, then that. A proxy, I noticed a typo there, is the function that acts as a substitute for another. So it's acting on behalf of something else. So if something stops here, then the next leg in that chain is possibly acting on behalf of it, just like a healthcare proxy. So if you're wondering, like, is this actually the protocol for it, or is this functional element acting on behalf of something else, like a healthcare proxy would act on behalf of somebody who isn't able to make decisions? Okay, so know the difference between policy, proxy, and protocol, because you're going to see those a lot in this section. So we're going to talk about signaling, transport, and protocols. And the first one on the list is our CAMA trunks. So if you've been in this profession for 10 minutes, you've probably heard the word CAMA trunks. CAMA stands for Centralized Automated Message Accounting. And some of these words just don't even make sense as to what the thing really is. But just know that CAMA trunks were necessary for our legacy 911 systems to work. So it is an analog transmission protocol. It transmits the telephone number via multi-frequency encoding. It was originally designed for billing purposes. So basically for long distance billing, actually. And they are used both between the end office and the selective router, as well as between the selective router and the PSAP. So when you think of CAMA, you think of CAMA trunks. It is the line in which our calls will ride in on into our legacy 911 equipment. So obviously with the advancements of next generation 911, we're going to see CAMA trunks going away. Analog systems, they're not serving much of a purpose now that we have digital stuff. dual tone multi-frequency, DTMF. Okay, this is the transmission of a selected number or symbol, like the star or the pound sign, right? On a phone, it's a pound sign. It's not a hashtag. On Twitter, it's a hashtag. On the phone, it's a pound sign. Okay, the generation of a specific pair of tones when that number or symbol is pressed on a push button telephone. So these tones are audible and they're transmitted within a voice band. So just to put into clarification, when you push a button on your phone, they all have a different tone, right? They have a tone associated with them. On push button phones, you may not hear it on a wireless device, but each number on the keypad has a DTMF tone, dual tone multi-frequency. And there are not a ton of places that this is thoroughly important for next generation 911, but it is important because I just want to share this little piece of information. So in Massachusetts, we have something called the silent call procedure. Up topper says most of the end office to tandem trunks are no longer using camera. They shifted to SS7. Yes. And we will talk about SS7 in just a few minutes. So thank you for sharing that. In Massachusetts, we have the silent call procedure. And with the silent call procedure, ever since we moved to our first internet-based 911 system, we have had actually it was before that. It was on the Mars equipment that we were actually able to do it. So with every RFP that went out, first we went from the Mars equipment, analog stuff, to our first Vesta. We had Vesta. I had Vesta Palace. Some folks have Vesta Meridian, but on the Vesta system, and then we moved to the CallWorks, Motorola CallWorks. And with each one of those systems, our state 911 department worked with our vendors to create the ability to recognize the DTMF, the tones that come in when somebody presses a number on their phone. And what that did is it allowed us to see what number the caller was pressing. So in the the silent call procedure here, we have a scripted, and you can Google Massachusetts silent call procedure to get what the script is. It's out there. But basically after we would check for the Americans with Disabilities Act by using TTY, we would go into the silent call procedure and say, if you need the police, press 1. If you need the fire department, press 2. If you need the EMS, press 3. And if they indicated that with a 3, maybe they're choking or having a stroke and they can't speak, we would say, so you indicated that you need an ambulance, press 4 for yes, 5 for no. And they would press the number and we could communicate that way. I do know that the Vesta Viper system, the Intrado Viper system also has this capability, because I'm working with an agency and we're just getting that turned on. But a lot of folks don't realize that capability exists. And what happens is when you push that button, a lot of times it engages the TTY and now you can communicate with your caller. So just another little big piece of information that I like to share, but that DTMF tone, that's what allows that to happen. So I want to talk about intelligent networks. There's a couple of different components. We're not getting super far into the weeds. If you recall, well, maybe I didn't say it in this one, but I'm going to say it here. When you take this exam, just understand that, especially when it comes to the new routing, the new mechanisms, you're probably not going to be asked on the process or where in the system things are, because everybody's system is going to be different. Everybody's system is going to use different components, different elements. Some are going to need this, some are going to need that. They don't need this, they don't need that. So we're going to first go through a ton of terminology, but don't worry, at the end of this session, I'm going to give you this 2 silly pictures that are going to kind of map everything out, and I'm hoping that'll help. So first, internet protocol, we know is a communication standard that enables computers to route communication traffic from one network to another as needed. If you don't know what internet protocol is yet, then we should go back to basics, right? The Integrated Service Digital Network, ISDN, and again, you know, I would spend some time understanding the acronyms for the exam, because there are places where they will use the acronym and you will not have the definition of what the letters stand for. So be careful with that. The ISDN is an international standard for public communication network to handle circuit switch digital voice, circuit switch data, and packet switch data. One of the things that you need to be clear on as we move to a next gen 911 framework is a lot of it has to do with packets of information that are going from one place to another, whether they're delivered as a whole or they're delivered as numbers, zeros and ones, and then they're put back together. They're all different types of intelligent networks, but this is just one of them. As Topper mentioned, the Signal 7 system, the SS7, I do feel like you're going to see a question on this. If I remember correctly, I do recall seeing a question on this. You can go very deep into this topic. I'm not going very deep into this topic because I don't think it's necessary to do that. But just know that it is a protocol used for setting up calls and providing the actual service. Okay. It is an out-of-band signaling system used to provide basic routing information, call setup, and other call termination functions. In this section, you're going to see different elements that are very familiar to, that are very similar to each other. So we have a lot of things that are setting up and maintaining and monitoring and terminating calls, but signaling system 7 is a signaling type system that assists in setting up those calls. So as Topper mentioned in the chat, it's working towards replacing those camera trunks. Okay, so signaling is removed from the voice channel itself and put on a separate data network. So that means what? It means that we can start getting more than just voice through these signaling systems. With SS7 comes some call path stuff. Now, again, I'm not going super deep into this because I think really you just need to know the definitions as to which one's which and which one does which. And I have two vehicle transportations here. So the NCAS and the CAS, so the non-call path associated signaling and the call path associated signaling have a lot to do with the way our wireless devices are routed into the 911 center. So this is how I want you to remember it, okay? So non-call path associated signaling is a method for delivery of wireless 911 calls in which the mobile directory number and other call associated data are passed from the mobile switching center, the MSC, to the PSAP, and it goes outside the voice path. So it's going outside the voice path. The call path associated signaling, CAS, is a method for delivery of wireless calls in which the mobile directory number and call associated data are passed from the MSC to the PSAP via the voice path. Okay. So if you think of it this way, the way the call that we prefer it to go is right from the mobile switching center, right to the 911 center, right? And if we're going right to the 911 center, this is how we want all the calls to go. So every piece of data, all the pieces of data, you think of them as people, Okay, so, and we're going to use those two forms of transportation there. We got the car, we can only fit a few people in the car, and that sporty car, he's going to want to drive fast and take shortcuts and go all over the place. So he's not going to take the traditional way that we go the same way every single day. So the non-call path is going outside, and it can only deliver 7 or 8 digits. And if you remember a few, maybe last week or the week before, when we were talking about wireless stuff, there was a time where the ability to send digits went from 7 or 8 to 20. Okay, so if we think of the non-call path going outside of the traditional routing, okay, and it can only bring a couple of numbers with us. You think of that smaller vehicle, faster vehicle, it's going outside, taking shortcuts, and it's going to try to get there by going a different path. The call path associated signaling, it's going to be able to accommodate at least 20 digits. So that's why I have the school bus there. And the school bus takes the same route every single day, right? It's a direct route from the bus, picks up the kids on the route and goes directly to the school. It doesn't go off, it doesn't go joyriding or anything like that. So whatever that does for you, if it helps you, it helped me understand that, you know, that non-call path is not taking the traditional routing, so not, and the call path associated signaling is going to take the route that it's intended to do, just like that school bus does. So take that for what it's worth. Frame relay is, again, we're getting into like the packet switching telecommunication service designed for cost-effective data transmission for intermittent traffic between local area networks and between endpoints in wide area networks. So what does that mean? I got a picture. Okay, so this is how I process it and understand it, is if we're taking information from one place, one router, one computer, wherever it is, if it has to go from that place over here, over there, and over there, there has to be mechanisms in place for it to do that. What frame relay does, and they put a little frame there, is it sends the data to one place, and then it can send it out to the 3 different places. So not needing as many features and functional elements along the way. So there's an image of frame relay for you. So again, for those that visualize it, without frame relay, goes from the router directly to the 3 components. And then with frame relay, it goes from the router, the computer, the system, to a central location, and then everything goes off from there. Multi-protocol label switching, MPLS, is a type of data carrying technique for high performance telecommunication networks that directs data from one network node to the next based on shorter path labels that rather than longer ones like network addresses. And then this way, it just gets there much quicker. So you think of labels, labeling of the data that's going. So it just creates shorter labels. So it can be identified quicker, where it's going can be identified quicker. So it is the multi-how-to route based on shorter labels. Make sense? Probably not, but I mean, that's all I got. Asynchronous transfer mode, ATM. This is, again, it's a signaling piece of the network based on packet switching. Again, it's broadband high-speed data transmission technology. It's used by our telcos to carry both voice and data at the same time, and it can run on any type of media. Session initiated protocol. Now, this is part of our, our older systems, our newer systems, but session initiated protocol, also called SIP, is a protocol that defines a method for establishing multimedia sessions over the internet. Now, I have a little picture there of Mike TV. Well, it's Mike TV's mom and grandpa from Willy Wonka or Charlie and the Chocolate Factory, whichever one you prefer. But this gives me the visual of what SIP actually does. SIP is what initiates the conversation. So think of Mike TV, right? He's standing on the thing, and the SIP is what takes him and puts him up in the air and sprinkles him over the air up there, and it's moving that information and data, and then it's going to terminate at the other end, or intended to terminate at the other end, but put it back together as it normally would. So SIP protocol initiates, terminates, and maintains that real-time data, right? Because they all looked up and they were like, oh, look, he's right there. He was literally moving from one place to the other. Now, when we think of it as being, over the internet or networks like that, but it's not the same as VoIP. One might confuse SIP with VoIP. SIP is the initiation of it. It is the movement of it, and it is the termination of it, that data going from one place to another. VoIP is the mechanism in which it goes. Now, if you need another visual, this is what SIP does. Here's another visual. If the Willy Wonka thing wasn't your thing, SIP is basically the one that starts the conversation. Hi. So it starts the conversation, and now the picture in the middle, they're maintaining that conversation. Okay, so one person talks, the next person talks, it's maintaining that conversation. And then at the end, it is SIP that terminates the conversation. Okay, so there you go. So now we're going to jump into the actual next generation 9-1 piece. This little piece of information was something that I found the last section, and I just thought it was a cool piece of information to have. Legacy routing always found the caller. Okay, so we would get the phone number, and the phone number would be based on the tower, and then it would deliver that on so the legacy routing would find the caller, because we would have to go back and find the caller information and move backwards, where NG routing actually finds the right PSAP based on where the caller is located. And I can't wait till we're in a place where that's how we're getting the location all the time. So what are the expectations of next generation 9-1-1? First, multimedia capabilities, text, video, telematics, additional data. Are we getting that stuff today? We are. But a lot of the places that we're getting it from are over-the-top solutions. So when agencies say that they're a next generation 9-1-1 environment, they're not a true next gen 9-1-1 environment until they're actually, just being on an ESI net doesn't make you a next gen PSAP or an I3 compliant PSAP, and we'll talk more about that in a few slides. We also expect better location from next generation 9-1-1, more accurate and faster location, better routing. This is what we grow to expect. But let me just be clear. Just because you have next generation equipment in your center, it doesn't mean you're getting better location. Okay, there was this big confusion when folks moved to some next gen 9-1-1 systems where it was IP based. They talked about how they were getting better location. I don't think they weren't getting better location, because the location wasn't actually changing from the carrier or the network. It was just able to be displayed quicker. It would get to the PSAP quicker, and they could identify it better on more updated mapping, etc. But there is an expectation of better location, which we will get there. We will get there at some point. Here in Massachusetts, we do geospatial routing as a state, and we're seeing that more accurate location, routing the call, not better location of the caller, if that makes sense, through the network. Wait, let me go back and rephrase that. What I know to be true is that the carriers, AT&T, T-Mobile, Verizon, US Cellular, all those, they're getting better at providing a device-based location. However, there's no way for the telecommunicator to know that that's the location that they're seeing on the screen. So when we expect better location from NG9-1-1, it isn't until we have true geospatial routing where that location will get more accurate. That's what I meant to say. More flexible operations, policy routing, virtual PSAPs, seamless call transfers. So like if I'm in Rochester, Massachusetts, and somebody in my jurisdiction calls me and says, help, I need help from my mom and she's in Connecticut, I should be able to just transfer that call pretty seamlessly versus jumping through a lot of hoops. And then resiliency, scalability, more modern and secure infrastructures. You know, being able to have a state-run system as cloud-based for sure. Kathy, we were the first in Illinois to go true next gen with some hiccups. Info comes with updated location much faster. Yeah, absolutely. You will get it much, much faster, but it's based on what the carrier is actually sending you. And I know that the carriers are sending better location today because the FCC report and order that we went over a couple weeks ago, where we're at 80 or 90% have to give, you know, within 50 meters 90% of the time. So we are getting better location, but the true next gen is allowing it to get there much faster, which we know seconds are important. So what do you actually get versus the expectation? So the core part of NG9-1-1 is replacing legacy infrastructure with modern infrastructure. A lot of cloud-based stuff, internet-based stuff, still using similar systems to the PSAPs, still relying on similar information from the callers. We're not getting a ton of information from the handsets yet. So again, when we think of a true next gen environment, I should be able to get video and pictures right in through my ESInet into my customer premise equipment, and we're not fully there yet. Some folks are starting to deploy capability and means to do that through their call handling, but I don't know of any centers that are getting all of that stuff through their call handling yet. An expanded view of next generation 911. Text to 911 was the first media type beyond voice. I always say this, when text to 911 came, people were freaking out, and look where we are today. Not a ton of people are texting 911. And I think we're going to see the same thing with additional information. So expanded view of NG9-1, getting location data from supplemental sources, such as Wi-Fi access points, Bluetooth beacons, barometric pressure, all that stuff. Pedestrian dead reckoning sensors, such as accelerometers, gyro sensors, all that stuff. And then additional data portals and web-based applications. So I do know that there is an app, Noonlight, that has been able to send a link into an alley screen. They've occupied a spot on the alley screen, but I don't know of any agencies that are allowed to click on said link that brings them to an external place to utilize a web application to be able to get additional caller information. So, but this is what we're looking to get. The NENA I3 standard defines end state architecture for core IP-based emergency service networks and applications. There are many functional elements. Some of them you will learn today. If you want more information on the NENA I3 standard, you can visit here and I'll put it in the follow-up email. But this is a lot of very high level technical things that we just don't need to go into right now. But just know that I3 is a standard by NENA that basically says, you know, this is the best way that we think our calls should be routing through the system. These are the things that we think you should have in place. So border control function, that's a place where it's going to make checks to make sure that nothing has cooties before getting into that system. So it will list things like that, like put a border control function in place, have an ECRF in place, have this in place, have that in place. That's what the I3 standard is, and it lists all the components as to what they think it makes the best architecture for a successful launch of next generation 911. So let's talk about the framework. So first of all, the ESI net. Now, with that said, I've heard people call it ESI net, and I've heard people call it an ESI net. What I will tell you is true technology-laden folks, as well as NENA, they call it ESI net. So that's what I'm going to stick to, just because I know that some folks get really upset if you call it an ESI net. I don't know why they get so upset, but it happened. So an ESI net is a managed IP network that is used for emergency services communications and which can be shared by all public safety agencies. Wouldn't it be cool if there was like a nationwide ESI net where everything was just connected and we all did the same thing? Yeah, that would be super cool. But that's not the case. ESI nets take advantage of broadband packet switching technology capable of carrying voice plus large amounts of varying types of data using IP standards and technology. So it's like a super highway, the interweb interconnection for 911. An ESI net may be interconnected at the local, regional, state, federal, national, or international levels to form an IP-based network of networks, and networks can enter the ESI net via IP or a gateway. And we're going to talk about gateways in just a little bit. A lot of folks get confused with some of the gateways, but I hope that by the time we're finished today, you'll have a better understanding based on the acronyms and just a better explanation of these gateways, but you'll see what happens. NG Core Services, Next Generation Core Services, NGCS, is the base set of services needed to process a 911 call on an ESI net. It includes all of these different terminologies: ESRP, emergency service routing proxy. So the proxy, that ESRP, is acting on behalf of something, which it's acting on behalf of the ECRF, the emergency call routing function. The core services include the LVF, location validation function, the BCF, border control function, or it's interchangeable with border control, just border control, a bridge, policy store, logging services, typical IP services such as DNS and DHCP. Now, the other ones, I'm not really sure what those are, but we're going to talk specifically about ESRP, ECRF, LVF, and BCF. Those are the ones that you really need to know here, okay? So we have
how to access the Emergency Response Data Platform. Any public safety agency can access life-saving emergency data through the RapidSOS Emergency Response Data Platform. There are two ways of doing so. RapidSOS Portal is a powerful web-based tool that enables you to manage emergencies and access location and supplemental data for every call in your jurisdiction. Signing up for Rapid SOS Portal is easy and only takes a few minutes. In addition to emergency management tools and data, Rapid SOS Portal includes a training platform as well as administrative tools to manage user permissions, track usage, and analyze trends in your agency. To learn more and sign up for Rapid SOS Portal, please visit rapidsosportal.com. Rapid SOS also integrates with every major CAD, CPE, mapping, or other public safety softwares. With an integration, you can receive Rapid SOS data through your existing workflow, and you won't need any additional screens, tabs, or windows. To learn more about integrations, visit rapidsos.com/public-safety-partners.
So we have something called the next generation functional elements. A functional element is defined as a set of software features that may be combined with hardware interfaces and operations on those interfaces to accomplish a defined task. The defined task that it is trying to accomplish is to get a 911 call through the next generation 911 system to the appropriate PSAP appropriately. So when I say get it to the appropriate PSAP appropriately, it may be a next generation type call that's going into a legacy 911 center, but we'll talk more about that. So this emergency call routing function. All right. So one of the biggest challenges I had when it came to the test was knowing the difference between all of these components. Two things. I made a couple of little pictures that maybe they will help you. Number one. Number two, I've mentioned this before, but I'm going to mention it again right here, especially for those of you who are going to start scramble studying because you're testing in early October. If you have not utilized the Quizlet app or on the computer or on your iPad, I highly recommend you do so, because this was extremely beneficial. By going through those flashcard type Quizlets was really helpful in helping me memorize the acronyms. But when it came to understand the functions, I had to do a little bit more work, and you're going to get access to that shortly as well. So the emergency call routing function. Take off the emergency, take off the function. This is your call routing in a next-gen environment. What was your call routing in the legacy environment? Your selective router. Selective router, SR. This one's the CR. This is your call routing. This, in a true next-generation 911 environment, the ECRF is what is going to route that call. So that's why you see a phone with a map there. So the ECRF is going to be what is routing that call. It's going to be what's determining where that call is going to need to go. Now, again, I'm just going to remind you, I'm going to go through these terms. They may not make sense, but then at the end, the last 2 or 3 slides, right towards the end, I have 2 slides with the pictures and the identifiable characteristics and the identifiable images. And we're going to go through the process. So the ECRF is an I3 functional element that is a lost protocol server. Lost is location service to translation. We will talk about that in a second. The ECRF uses a location, either a civic address or a geodetic coordinates, and a service URN as input to mapping function and returns a URI. Do you need to remember all that stuff? Nope. What you need to know is that when the 911 call gets placed, the ECRF is going to use its special powers to identify where that call needs to go based on a few things that are going to happen before it. It is geospatial routing that replaces the MSEG-based routing, and this ECRF replaces that selective router. The emergency services routing proxy, it's acting on behalf of something. And when I show you the image, I'll show you it is actually acting on behalf of the emergency call routing function. The emergency call routing function picks the location that it's going to go, and then it stops there. And then the ESRP, the emergency service routing proxy, picks up where it left off. So this is an I3 functional element, which is a SIP, session initiation protocol, proxy server proxy on behalf of, that selects the next hop routing within the ESI net based on the location and policy. A hop is a route. So I don't know why I think of this, that when I try to think of things in the way that they like, it just, this is the way my brain works. When I think of a hop, it's which route this particular call is going to take based on the location of the caller and the policy that goes with it. So I'm going to get a little bit more detail into the picture. But for whatever reason, when I was trying to think of how to describe a hop, I was thinking of being in a candy store. You know, the candy store that has all the things lined up on the wall, the tubes on the wall with all the candy in it. I just imagine a rabbit hopping from one to the other, and then he's deciding which tube he's going to go down, which route he's going to go down, which candy he wants. I don't know why I thought of it that way, but that's the way that I thought about it, because it makes me think of like picking something. Okay. So the bunny is hopping from one thing of candy to the other. Stupid, I know, but nonetheless, it might help somebody. And we'll talk more about that and how it works in just a little bit. I know some of the stuff is super confusing, but when you see the pictures, I feel like it's going to make a difference. There is an ESRP on the edge of the ESI net. There is usually an ESRP at the entrance to the NG9-1 PSAP itself. And there may be one or more in between somewhere. So we know that there's at least two, to make sure that all of the checks and balances are in place. So when you look at the little ESRP dude that I have there, I don't know why the text is above the little box, but it's supposed to be in there. Think of the ESRP, the routing proxy, as a healthcare proxy. If you're a healthcare proxy for somebody, chances are somebody gave you a list of things that you have to follow. I can't see somebody saying, oh, I want you to be my healthcare proxy, and then not expressing your wishes. So if somebody, and I know this is kind of morbid, but it's just the way that I remember it, as far as the emergency service routing proxy, is when my father asked me to be his proxy, he made it very clear that there were things that he did not want. If he was to ever need to be put on a ventilator, he didn't want that. He did not want to be resuscitated, a do not resuscitate order. So as a healthcare proxy, I had to make sure that I checked off all the boxes for all the things that he wanted. The same goes true for the emergency service routing proxy. When that 911 call leaves the ECRF decides this is where the call is going to go based on the information that it has from all of the pieces prior to it. And then it gets to the ESRP. The ESRP now has to say, all right, you've gotten through the border control function. You don't have cooties. I just need to look ahead and make sure that everything is clear. I need to make sure that the PSAP is ready to receive it. I need to make sure there's no broken links in the chain. I need to make sure that there isn't some major catastrophe. So that emergency service routing proxy, like a healthcare proxy, has to check up all the boxes before the call can continue to the PSAP in which it is going to. Location validation function, the LVF. It is a functional element in the next-gen core service that is also a lost protocol server where civic locations are validated against authoritative GIS data. So the LVF asks the GIS database, is this location valid? And then it's able to pull it back in and say, yes, it is. It's one of the checkboxes. A civic address is considered valid if it can be located within the database uniquely and is suitable to provide an accurate route for the 911 call. The LVF replaces the MSAG for address validation purposes. So true NG9-1 environments, there's no more MSAG. A location information server is a functional element. So these are all functional elements in the next gen 911 system core services. It's an IP capable originating network that provides location of endpoints. It uses, actually, hold on, that held is on a different screen. I had them both on the same screen before and I forgot to take that one off. So just specifically about the location information server, it is a cloud-based location information server that is based on location information and data that is received from a source. There are many different location information servers. There isn't just one, okay? So RapidSOS has one, Intretto has one, Red Sky has one. If Tracy Eldridge wanted to have a location information server, I could totally do that. But where am I getting my location from? Okay, so I will use the RapidSOS infrastructure as an example, because I know that the RapidSOS location information server gets its location information from the operating systems on device-based hybrid location from Apple and Android devices. It also gets location information from other sources, but it is a cloud-based storage for location. So location information server. Border control function or border control. I've seen it both places. It's interchangeable. Just because they put function on the end doesn't mean that it's not the same thing. Border control function. It provides a secure entry into the ESI net for emergency calls presented to the network. The BCF incorporates a firewall admission control and may include anchoring of a session and media, as well as other security mechanisms to prevent deliberate or malicious attacks on the PSAP or other entities connected to the ESI net. There are several BCFs throughout the network. What is a I3 PSAP? It is a next-gen public safety answering point. It basically denotes a PSAP. Oh, apparently I was dyslexic. I'll change that when you get it. It denotes a PSAP that's capable of processing calls and accessing data services as defined in the NENA I3 specification. So it's a true NG 9-1 PSAP. EIDO, Emergency Incident Data Object. So NENA has adopted the JavaScript object notation. That's just the way that the information, how they understand it, okay? In short, EIDO, it is used to share emergency incident information between and among authorized entities on the system. It can be used for, as you see on that second to last bullet, it provides a standardized way to send incident data to EOCs, tow truck operators, utilities, news organizations, other public safety entities. You can pick and choose the data and the packets that is being sent this way, but the EIDO and its conveyance mechanisms replace the serial port data connection between the CPE and the CAD, as well as providing a standardized CAD to CAD interface or a CAD to something else, right? So if I wanted to, I don't know if folks recall or if they've had the opportunity, but we had a serial port connection where the information from your 911 call handling solution can dump that data and information into your CAD. Now, if I wanted that to go somewhere else, to say, if I was the communication center and I wanted it to go to a neighboring police department or the tow company or to somebody else, an EIDO would be the way for that to happen. Spatial interface. This is actually this is one of the functional elements. On the top it says it is a functional element. On the bottom it says it's the transport interface itself is not a functional element, but the spatial interface is, if that makes sense. But it's a standardized interface between GIS and the functional elements. So let me rephrase that. It is not actually a functional element. It is part of the functional element process. So it is a standardized interface between GIS and the functional elements that consume the GIS, such as ECRF, LBF, mapping data, and geocode service. And you'll see what I mean in the picture. The forest guide. This is just so randomly placed in there. I do feel like I've seen a question on the forest guide. I hope this picture helps put into perspective what the forest guide might actually be versus what you might think it is. A forest guide to me means where the national parks where I could go see some forests. Nope, that's not what it is. The forest guide is a place of resolution for a 911 call to get to the appropriate local 911 center if the call is out of the area. It is part of the loss protocol, which we're going to talk about in just a couple of slides. All it does is help the emergency call routing function contact the correct one outside of the area by redirecting lost queries. Each state is going to have one. So basically the 911 call, so I wanted a tree with a map because they call this a tree. They call the forest guide a tree, in which if the call comes in here, it's going to go this way, this way, this way, this way. So it kind of looks like a tree, just like a phone calling tree that you think of. That's why they call it a forest guide, because it encompasses call routing trees in each jurisdiction. So each state will have at least one. Some states will have multiple ones. DNS server is a global distributed delegated database of records about domain names. That's the extent in which I know about it. You'll have these definitions here. I really don't know how to explain much more of that, so I'm just closing that, but this is more the technical side of stuff, but your definitions are there for that. An NG9-1-1 transitional element is a location database, LDB, is a server that retains all the current information functionality and interfaces of today's ALI and can utilize the new protocols required in an NG9-1 deployment. And you'll see that in the picture. So when we talk about this location, for these databases, for the list, the location information server, where is this location coming from? So when we're talking about the carriers, the OSPs, the originating service providers, this location is used for geospatial routing. It's used to display the location in the PSAP, and it's focused on compliance, meeting the FCC requirements. The FCC requirements is based on NENA I3 standards. There are also third-party providers of location. Okay, so when the carrier send it, this is what you get. But then you have the third-party providers such as Rapid SOS and Rapid Deploy. The difference is these locations, these over-the-top device-based hybrid locations that are coming from the operating system and not the carrier, are not used for routing today. Hopefully, they will be used for routing at some point. Okay. It's used to display the location at the PSAP, and it's focused on speed and accuracy, helping the PSAPs actually find the caller. Here's some more transitional elements. So these gateways, there's going to be 3 gateways listed here. And then you're going to see them in the picture, and they'll make more sense when you see them in the picture. So know your gateways. That I do know. There are a couple of gateway questions on your exam. Legacy, network, gateway. So if you think of an agency that has not upgraded anything to next generation 911 yet, okay? So it is a legacy network. For a NG type 911 call to transverse into that legacy network, it has to go through a gateway. And when you think of a gateway, I want you to think of just a small device, maybe looks like a router or something, where it transforms the type of call that's coming in to the type of place that it is being received. So that gateway it allows the call type to enter into an unfamiliar place, and it's going to change it into something else. Okay. So the legacy network gateway, it provides an interface between non-upgraded legacy originating network and a next-gen core service enabled network. The legacy PSAP gateway is the changing of it before it gets into the 911 center. So say it was the calls coming from a next gen core service type call, and it gets to a non NG9-1-1 PSAP. Before it goes in the door of the PSAP, it has to be changed into the ability to go into the PSAP. So legacy PSAP gateway provides an interconnection point between the ESI net and the legacy PSAP. It's used in call delivery, transfers, and alternate routing when legacy PSAPs need to interact with an ESI net, okay? And then legacy selective router gateways, LSRG, just like the normal selective routers, they're going away. You're not going to see these a whole lot. You're not going to see this a lot either. This is a very rare occurrence. It may happen once in a lifetime, but it's not something you would see often. But the legacy selective router gateway provides an interface between a 911 selective router and an ESI net, enabling calls to be routed and or transferred between a legacy and NG network. And these will make more sense when you see the pictures. So this is just a generic picture. This is not the one that I'm referring to, but this is just a quick overview of some of the components that we have talked about and where they might sit in the call processing. Okay. So when we have a legacy network call up there in the left hand corner, and it's using a voice path to enter into a next gen 911 environment, we have the legacy network gateway, has to go through a border control function where it needs to be checked. It's going to go through all of these places right here. We'll talk about that in just a second, using the policy routing function. And before it gets into the 911 center, okay, it's going to, so if this is a legacy network over here and it's going through the system, it's going to need to, first, to get onto the next gen system, it's going to go through the legacy network gateway. And then to get from this next gen 911 environment into that legacy PSAP, it's going to go through the legacy PSAP gateway. So think of the words as it's describing it. If it's a legacy PSAP gateway, it's going to be that last stop right before the PSAP. If it's a legacy network gateway, it's going to be for them to get onto the network itself. Okay. And then a couple more terms that we're going to go over, and then we'll go through the entire process and put all the pieces to the puzzle again together. Presence information data format location object PIDFlow. That's what it's pronounced as. It provides a flexible and versatile means to represent location information in a SIP header using XML schema, whatever it is. I'm going to show you my definition in just a few minutes on the picture, and it's going to make more sense. But basically, it may contain geodesic or civil location information. It's provided by a device or a service provider via a location information server. So it is actually the data packet of location. It is the I don't know how to get you to remember it until I show you the picture. But think of it as next gen alley minus some things like subscriber or carrier name. Okay, so it's the location information. It's next generation alley. It's the data packet of location and stuff that is going to normally follow the call, just like alley would appear in the center. But it's that packet. It's a packet of data. So remember that. Here are your definitions. I do not recall any seeing this stuff anyplace. I don't recall it being I feel like there is some stuff on the exam, but to be totally honest with you, this is not something I'm super familiar with. But what I do know is these are the definitions that you're best suited looking at and understanding. I wouldn't spend a ton of time here. That's just my advice, but it's there. Next generation 911 security, NG-SEC, defines a holistic security standard for NG9-1-1, and there's a standard that is accommodating that. The policy routing function, you will see this. I do recall seeing this on there. And again, I hate to sound like a broken record, but I'm going to say these things, and if they're confusing, wait, when you see the pictures, when you see the map, you'll get it. But the policy routing function is just that. It's a policy. If this, then that. It determines the next hop in the SIP signaling path using a policy. So there are two types: call management rules and routing policy rules. The call management rules modify call flow within the NG system prior to the PSAP call delivery. So it's basically making the decision on which hop is going to be the one that we're going to use for whatever reason, based on the information that it has. If this, then that. The policy says we're routing it this way. And then routing policy modify normal call routing for a time, date, PSAP availability, or similar condition. So the call management rules are basically, this is how it's going to go on every day. So if I'm in this seat right here and I dial 911, it's going to go to the ROC, my regional center. That's what the policy says. It says if I'm physically located here, the call's going to the ROC. Now, God forbid something happened to the phone system, to the network, to where it's going to go. They got to think on the fly. They got to go to the policy and say, but if this gets in the way, if there's a detour, if there's a problem, what does the policy say now? If the Rochester 911 center is not accessible based on this routing, what's the next thing? And here in my 911 center, it goes to the town of Marion. So it is the policy routing function that says the call will go to Marion. We already did that one. An additional data repository is a data storage facility for additional data. The ADR, okay, dereferences a URI path, blah, blah, blah. Basically what an ADR is it is a cloud-based place for all the additional data to go. So just like at Rapid SOS, They use the location information server and an additional data repository. So anybody that is willing to send data, which is all of these additional sources, medical alert, the emergency profile setup that they have, Sirius XM radio, anything that's going to provide additional data is going to go to the additional data repository first, and then it will be able to go. Ethan, if the call routes to a different PSAP, does the call center know it went there by design? No, I mean, if I'm understanding your question correctly, I'll give you an example. In 2012, and only because I just shared a picture on my Facebook page regarding this storm that happened, and I touched on it in a previous session a couple weeks ago. In my 911 center in 2012, we had a massive power outage, and the battery backup to the node in which housed all of our 911 trunks and all that, like, allowed the call to go there, was down. It was busy. It wouldn't allow the call to go through. So if I'm just sitting there in my 911 center, I wouldn't know that my calls were going to Marion unless I knew, right? So Marion starts getting all our calls. They're calling us, telling us that the system went down. Now, if that's not the question you ask, if the question you asked is this something that gets set up in advance prior to a major incident? Yes, absolutely. Most 911 centers have its rollover or alternate routing set up in advance. The alternate routing is, if you can't get here, then my backup, my understudy, the alternate, just like in a play, the alternate is going to step up and take that call. And then when if the call doesn't know where to go at all, so say somewhere there's a glitch, something happens, and here's this example. So we had a call where the person was in our town, but their VoIP phone system for work was addressed to their main facility in Braintree, which is like an hour away. So the phone system is seeing one location, the network is seeing another location, and the call didn't know where to go. I don't know if I should go here. I don't know if I should go here. So it sent the call to Northern 911 in Canada, and that was default routing. To know where our alternates are, yes, we should know that in advance. Our default routing, you may not know, because it's going to be based on what type of phone, what type of problem happened with the phone. Does that make sense? Yes, hopefully. Awesome. Identifiable searchable additional data repository is an ADR that provides a service that can search for additional data by the URI. So at Rapid SOS, when Rapid Light was available, you used to be able to type in the phone number, and any additional data that was associated to that phone number would be able to be brought back onto the Rapid Light screen. Now with Rapid SOS portal, you get additional data information that automatically gets pushed through, which is super cool. Here is this loss protocol, which I now know I should probably put the loss protocol at the beginning, because there's a lot of things that are referring back to the loss protocol. And again, the picture will make sense, but loss protocol is location to service translation. The abbreviation is LO, capital L, lowercase o, capital ST. The LO is for location. The ST is service translation. It is a protocol that takes location information and a service URI, URN, and returns a URI. Is that relevant? Nope. Understanding the process should be. It's used generally for location-based routing. And in a next-gen 911, it is used as the protocol for ECRF and LVF. If you notice, there is an unaddressed letter there. That's going to be part of the picture that I'm going to show you in a few minutes. The loss protocol is what gets used to find the address for the letter to be mailed. And in this case, the letter there that you see there is the 911 call. So until the lost protocol finds the address, because it's lost, this mail, the call, it's lost. It has no address. It has no idea where to go. It will use the lost protocol to gather that address or location that the call is going to go. HTTP enabled location delivery, also called HELD, is a protocol that can be used to acquire location information from the location information server. And it's more of a pathway. All right, cool. So we got to go back to basics as far as the emergency call routing goes. This is the old time system. This is when an old grandma's phone on the wall wants to get into a next gen system. And I'm going over this because I've had a couple of questions that folks needed clarification on, and this is where I'm going to also make that clarification. So this is regular PSTN phone call, public switch telephone network. This is your grandma's phone, right? Phone on the wall. When that 911 call gets placed, it goes to a central office or end office. CO and EO, they can be used interchangeably. Okay, some folks get a little confused. What's the difference? There really isn't a whole lot of a difference. When that call gets to the CO and the EO, it then goes to the selective router. The selective router, now based on the phone number, determines where that call is going to go. Okay. And when we decide where that call is going to go, if it's going, now this is going to be a little sidebar, but you have to understand, because you might see this on the exam. So I think you can see my mouse. Hank, can you shake my head? Can you shake your head? Can you see my mouse moving? Okay. Because I'm not sure if you can or not. Okay. So call gets placed, goes to the CO, then goes to the selective router. The selective router is going to determine, this is an old style system. Selective router determines where, hold on one second. Kids home, had to close the door. So selective router is going to determine where is it going to go. It's going to pick one of three places, right? Well, it's going to go to a PSAP. We know that anyway, but which kind of PSAP is it going to go to? Is it going to go to a legacy PSAP? Is it going to go through to a I3 next generation 911 center, a PSAP that doesn't go through the ESI net? Or is it going to go to the ESI net? Okay. So again, just go back. This is your grandma's phone. It's going to go to the CEO, and then it's going to determine which way am I going to go. The 911 system is famous for, all right, this is something new, so we got to put a couple of Band-Aids in place and a couple of impromptu things to get it through the system. Okay. So if it's going to go directly to a regular 911 system without next gen in place at all, the public system telephone network switched phone goes to the CEO, goes to the selective router, okay, may dip into the MSAG to validate some information, and the selective router database is going to validate some of that information, and then it's going to send it right to the legacy PSAP. That's all based on the phone number, just the phone number at this point, okay? So there's one of the exam questions, number 77, to be specific, where a lot of folks think that Annie and Allie are traveling through the network together. Like, you know, Big Al, little Annie, they're not always together. Okay. So basically up until here, we only have the phone number. We only have the Annie. So when it gets to the PSAP, that equipment is now going to go ahead and dip into the Allie database. Allie, Big Al. Now it wants all the information. Okay. So just because we see those two things together when they're displayed, all of this is happening behind the scenes. So selective routed to the legacy PSAP. Once that phone number, the Annie, gets there based on, remember the emergency service zone number, this selective router based on this phone number and the minimum location stuff they can get, it delivers it to the right PSAP. The MSEG is delivering it to the right PSAP. It's not delivering the address information. The MSEG and the SRDB is being used to validate that this is the right place it's going to go, but it's not bringing back that additional location information. It doesn't get that until it does a dip of that once it gets to the PSAP. So here's my phrase for that. Just because Annie and Allie display together, they don't always play together, right? So they're not coming down the pike together. So they're separate. So what actually is routing the call? That Annie information, the phone number, and the emergency service zone number, not Allie. Allie is not determining that. They're not getting Allie until it reaches the PSAP. So that's that. Okay. Now, if that call is your your grandma's phone, and your community has an ESI net in place, then it's going to take a different route. So it's going to go to the CO or the endo, just like it normally does. It's going to go to the selective router, and then it's going to go to whichever telco is going to deliver it to the ESI net. And in this case, this is where the legacy network gateway is going to be. This is all old legacy network. Okay. Your grandma's phone. Okay. This is all legacy stuff back here, but I need to get it on the new stuff. So this is the gateway, legacy network gateway, that's going to allow it to get onto the ESI net. Okay. We're going to go over all this stuff after. So once we get to this point, but I wanted to put it on both pictures. So if you're following the path, it'll make sense. But now this right here, the legacy selective router gateway, the only time you're going to see the legacy selective router gateway is if the call is going from the legacy equipment right directly to a next gen PSAP. I don't know of any PSAP that is a standalone next gen PSAP that isn't utilizing the ESI net. But just in case there is, this LSRG, this legacy selective router gateway. So legacy selective routers over here, the gateway to get into next gen PSAPs. I hope that makes sense. Okay. So now we're going to put it together with all of these other terms that we have been referring to. Okay. So that was your grandma's phone that was on the wall. That was the old telephone system. Now, if we're going to place a 911 call from, say, a cable company type phone service, which is IP based, a wireless device, or a computer based phone system, right? So these all have various types. These calls, when the call is placed, it's going to take a quick job. These three types of systems are going to use the held protocol, and it's going to send it to a held server, and then it's going to use the lost protocol. Okay. So 911 call gets placed. It really doesn't know where to go. So how does it figure out where to go? It has no address. It can't go anywhere. So it's going to use the lost protocol. The 911 call originally says, hey, I'm lost, right? So I got to figure out what the address is. So I take that blank envelope and I just throw it out there, and it's got to find out where it goes. So using the lost protocol, this empty envelope with no address is going to dip into a location information server. There are many different companies that have location information servers. There isn't just one. Okay, Intrado has one, Rapid SOS has one. I don't even know, Red Sky has one. All of these manufacturer companies, nobody owns the list, the only list that gets queried in the next gen 9-1 process. Okay, so now using held technology, the call sent to the held server, using lost protocol, this empty envelope, it's going to dip in and it's going to say, hey, location information server, where is this person? Because until we know where the person is, we can't route the call. So now that list, that location information server, takes the information and sends it to the ESI net. And that is what PIDFlow is. It's the contents of the envelope and the address on the envelope that actually tells it where to go. Okay, so now we're starting to use this process. Now we get to the beginning of the ESI net. There's a border control function, a BCF. That border control function says stop. It's like the moose in National Lampoon's Vacation, right? Stop. Can't go in. Got to pat you down, got to make sure that everything's on the up and up. Are you really a 911 call? Are you trying to scam us? Are you a spoofer? What are you doing? So the border control function, you're going to see a few of those throughout the process. So you don't need to know exactly where they are. You need to know what they do and why they're being stood up. They're stopping the process to say, all right, I'm going to do a check. I'm going to do a validation, make sure that everything's cool. So now that envelope with the contents, the PIDFlow information is going to jump onto the ESI net. It's going to truck on down the ESI net and it's going to get to that emergency call routing function. The emergency call routing function is going to say, oh, hey, PIDFlow, let's see, what is your address? Okay, yes, border control, April. The terms are interchangeable. Sorry about that. They are interchangeable. Okay. So the ECRF, the emergency call routing function, is going to say, hey, PIDFlow, based on your contents and your address, it looks like this call needs to go to Rochester. So I'm going to go ahead and let you pass, and we're going to send you onto the ESRP to make sure that everything checks out and that you can continue on to Rochester. But in the meantime, I'm just going to do a couple of more validation checks. You see all these arrows going to different things. So this ECRF is going to go, based on the information I have, you're going to go to Rochester. However, I'm just going to briefly check. I'm going to check SI. SI is spatial interface. Spatial interface knocks on the door of GIS, this little dude right here, and says, hey, is this what you're getting to? Is this valid? Is this address legit? And then it's going to come back to the ECRF. At the same time, it's going to send out that address and all that information that I got from PIDFlow, and it's going to check the location verification function. The location verification function can't say yes or no until it has checked another LIS, location information server. So once it dips there, comes back, then it goes back to the ECRF. So the emergency call routing function is now going to send that call on its merry way, and the ECRF is done in the process. It's going to get to the ESRP, the emergency service routing proxy. But before it gets there, it's going to go through another border control check. Okay, border control function. The ESRP is going to take all of that information, all of the data, and it's going to check off all the boxes. It's going to say, yes, you need to go to Rochester. And I'm just going to take a look on my GPS and I'm going to check out, make sure there's no accidents along the route. I'm going to make sure that there's no detours. There's no issues that are going to prevent you from getting there. And then it's going to send it. And when it sends it, it's going to send it to either an I3 ready PSAP, which is going to have another border control function before the PSAP that says, hey, just going to check you out because there's a lot of stuff that happened between here. You could have picked up cooties along the way. So as long as you don't have cooties, we're going to go ahead and let you in to that PSAP. If the PSAP is not I3 ready, if it is not an Next Gen 9-1 center, it's going to take the route and it's going to go towards the legacy PSAP. But before it can be entered into that PSAP, it's going to be converted again. It's got to go through a gateway, the legacy PSAP gateway. That legacy PSAP gateway is going to send that data and that information to the next stop. It's going to say, okay, you can pass go, you can collect $200, but we're going to stop you here. We're going to check, make sure you don't have cooties, and then we're going to let you into the legacy PSAP. Now, there's one more thing that I want to point out here, this PRF, policy routing function. So as long as everything checks out at the ECRF, it's going to move on to the ESRP. Okay. Once the ESRP determines it's going to go, it can go. It's going to pick the road that it needs to take. It's going to pick the hop. It's going to pick the route that it's going to take. Emergency Service Routing Proxy. It's acting on behalf of the ESRP. So in theory, the ESRP is the router, right? It's going to route it. But now the ESRP is acting on behalf of this first routing mechanism. He's done with his job. He's going to act on behalf of that. When there is a detour, when there is a sign put up, when there's a moose that says, no, no, you can't get in there, then the ESRP is going to check with the PRF, the policy routing function, and it's going to say, hey, where, oh, I don't know why that changed. It's going to say, okay, policy routing function, based on the information that I've gathered, all checks aren't in place, and I need to send it to another PSAP. So the policy routing function is going to say, all right, if you can't send it to Rochester, we're going to go ahead and send it to Marion, and then it's going to send the call on its way, and then it's going to check another ESRP over here, and then maybe even another one before it gets to the PSAP, and all of the validations are in check. Got that? Ready to take your test? I know it's a lot, but I thought it was important to, one, do it live while we were together, and have the opportunity for anybody to ask questions. And if you don't have questions now, or you do have questions later, please let me know. I hope that makes sense. But now we're going to continue on. If you go to YouTube and go to Commercial Electronics Corp, go under their videos. This video, 911 Technology for Non-Engineers, How the Magic Happens, and 911 Technology for Non-Engineers, Episode 2, the rest of the story. Beth English did these two videos, and she talks about some of the stuff that I just talked about here, but she was extremely helpful in helping me understand it when I first did it. So I love to give these as a reference. They were really helpful in understanding how all of this stuff works. So with that, repeat the site. Hold on. It's on YouTube. So if you just went to YouTube and up in the search bar, just put in Commercial Electronics Corp, and it'll bring you to their channel. When you go on to their channel, go under videos. It'll say either all or videos, and look for these two pictures right here. That's the icon. And then the first one is 911 Technology for Non-Engineers, How the Magic Happens. And then the second one is the rest of the story. So with that, she breaks some of these things down into a very usable thought process, and if you combine that with the video of those two maps, I was hyping you guys all up and I had it all down, but my brain seems to be fried at the moment. But it reiterates a lot of the stuff that you're going to get, and I think it should be super beneficial. So with that, my friends, here's my contact information. I know that those of you that are on here probably have it, but if you're watching it outside of the study group, here is my contact information. My podcast is up in the right-hand corner. In the lower right-hand corner is the On Scene First Safety Net private Facebook group for first responders for mental health and wellness. So I appreciate you and all that you do. And from the bottom of my heart, folks, Stay safe, stay strong, and stay here. We need you.